Hi guys, so welcome to day 12 of our algebra review camp. So today we'll continue talking about the radicals. But in yesterday we talked about what is the meaning of the radicals. So today we'll be talking about how we can do some operations with the radicals. Okay, so now we'll first look at the addition and subtraction. So how can we add or subtract two polynomials, two radicals? Okay, so if we have the same radical in this operation, so we have the, oops. So if we have a root 3 and then we have another root 3, that means we can combine them using the distributive property, right? So you can imagine the root 3 is just a letter, and because we have, say, a plus 2a equals to 3a. So that's how we can do the addition or subtraction with the radicals. Okay, so as long as they are the same radicals, then we can add or subtract them. And just like we can combine the coefficient. Okay, and if we have different radicals, like here, because we just talked about that, okay, in yesterday that square root of 2 and square root of 3 would not be rational numbers. Okay, so we cannot just add them together and get the results because we know that the result will be another irrational number. Okay, so we cannot just add these two together and have the result. So if we have a root 2 plus root 3, we can just leave that as it is. So it's like if you have a plus b, then it's sufficient to just write it as a plus b. Okay, but for the multiplication and division, it's a little bit more complicated because now we can actually do some operations. So if we have a square root of a times a square root of b, so we can actually multiply this together. So unlike the addition, which we cannot do any operations, for the multiplication, we can actually do that. Because if we have, okay, square root of a times the square root of b, and let's say that just equals to a square root of a times b. Okay, how do we prove this? So we can first square these two together. So we have the square root of a times square root of b to the power of 2, and then we have square root of a b to the power of 2, right? So on the left hand side, we just have a square root of a times 2, and then square root of b times 2, and then that equals to ab, right? So we have ab equals to ab, right? So to complete the proof, we just to go from the last step and to the first step, so that we have our proof. Okay, so we can prove that if we have a multiplication of the radicals, we can actually do this operation. Okay, and same goes for the division. So if you are interested, we can also try to prove this property for division as well. Okay, and now let's take a look at the practice. So for the first one, if we see addition, it's like how we can do addition with any algebra expressions. So we first look for the like terms. Okay, so here we have a root 3 and then we have another root 3. So we can actually combine them using the distributive property. So the result will be 4 and root 3. Okay, so that is what we have for the root 3. And then we go to the next one. So we have a 2 root 5 and then 4 root 5, minus 4 root 5. So combine them, we have a minus 2 root 5. Okay, so that is how we can do addition and subtraction. And we should stop here because we have two different radicals and then we cannot do subtraction with two different radicals. Okay, and for the second question, we actually have a multiplication. So if we have a multiplication or division, we can actually do the operations within the radicals. So for this one, we have a square root of 6 times 24, and which equals to a square root of 144. And because this is a perfect square, so we know that equals to 12. Okay, so the final result is 12. And for division, it's the same idea. So we just have a square root of 24 over 6, which equals to the square root of 4, and that equals to 2. Okay, so that is how we can do the operation with the addition and subtraction and also multiplication and division. Okay, so let's use the other practice problems to see if you can master this idea. Okay, so I will see you guys tomorrow. Bye.